Sorry everybody, I thought my video got cut out because I had a sign saying my phone showed that was low battery, so I thought it cut out my video. Okay, so continue with the questions here. So the B says, what would happen to the standard deviation if the first measurement was 1.5? Okay, so our first measurement here is 1.7. Okay, so if this 1.7 was then changed to a 1.5, we're saying what would happen to our standard deviation? Well, the question you should ask yourself is this 1.5 closer to the average than 1.7, or is it further away? Okay, so our average is 1.82, so 1.7 is actually closer to the average than 1.5. So if we change the 1.7 to a 1.5, then that would create a wider result of values. Sorry, the values would be further apart. So if my values are further apart, that would increase my standard deviation. So what would happen? The standard deviation will increase. Okay, now C says, what would happen to the standard deviation if the second measurement was 1.7 instead of 1.4? Okay, so going to the second one here. So if we change this 1.4 to a 1.7, what would happen to my standard deviation? Well, 1.4 is further away from the average than 1.7. So if we change it to 1.7, we would actually be closer to the average. Okay, so since we're closer to the average, then the standard deviation will decrease because our values aren't as spread out. So the standard deviation will decrease. So remember, the lower the standard deviation, the less spread out the values are. The higher the standard deviation, the more spread out the values are. Okay, now this is a kind of a trick question here, D. If all the values were 1 decibel lower, what would happen to the standard deviation? So what that means is if I changed all of my results up here by 1 decibel lower, so if it was 0.7, 0.4, 0.9, 0.7, 0.5, 1.0, 1.1, 0.8, 1.2, and 0.9. So if I changed all these results by 1 decibel and made them lower, so I have these values here, what would happen to my standard deviation? So remember, standard deviation is the average distance the scores are from the mean. The greater the spread, the greater the standard deviation. So if you look at the values, if they're all decreased by 1, they still have the same amount of spread. So these values here, so going from 1.4 up to 2.2 is a spread of 0.8. And if I did over here from 0.4 to 1.2, that is also a spread of 0.8. So if they all decrease by 1, the standard deviation actually stays the same because the spread of values is the same. So the standard deviation stays the same. Okay, the spread of the values are the same. Okay, now E, which values are more than 1 standard deviation from the mean? Okay, so the mean is 1.82. So we want to know which values are further than 1 standard deviation away from 1.8. Okay, so we're going to break it up into 2 parts. So our standard deviation we calculated was 0.24. Okay, so if we subtract 0.42, 0.24, and we add 0.24, we'll see if any values are below this one here or higher than the results here. So 1.82 minus 0.24, so 1.58, and okay, so we want to know, do we have any values that are further than 1 standard deviation from the average? So do we have any values that are lower than 1.58 or any values higher than 2.06? Okay, so do we have anything lower than 1.58? Yes, we do. We have 1.5 and 1.4. So 1.4 and 1.5. And do we have any values that are higher than 2.06? Yes, we do. We have 2.1 and 2.2. Okay, so these 4 values are more or further than 1 standard deviation away from the average. Okay, now we're going to calculate the Z-score. So calculate the Z-score of a rating of 1.7 decibels and interpret its meaning. So going back to our formula sheet here, so our Z-score is the X value, subtract the average, divided by our standard deviation. So our X value in this case is 1.7. Subtract our average, which is 1.82, divided by our standard deviation of 0.24. So we have an answer of negative 0.5. So we get a Z-score of negative 0.5. In chapter 7, we'll talk about what this value means further. But for us, going back to the definition, the Z-score is the number of standard deviation and observation is from the average. So the 1.7 is 0.5 standard deviations lower. So since it's a negative, it is lower. So 0.5 standard deviations, I'm going to write this out. 0.5 standard deviations lower. So again, the negative represents lower than the mean. Okay, and lastly, calculate the Z-score of 2.2 and compare it to 1.7. So if we did 2.2, subtract 1.82, divided by 0.24, we get, let me do it again. .58, I'll round to 1.6. Okay, so 1.6. So a rating of 2.2, 2.2 is 1.6 standard deviations higher than the mean. Okay, so 2.2 is 1.6 standard deviations higher than the mean. Okay, and to compare the two, so we had 1.7 give us a standard deviation of 0.5, and a 2.2 give us a standard deviation of 1.6. Okay, so what that tells us is the 2.2 is much further away from the average than 1.7 is. Okay, so this is quite a ways away from the average as opposed to the 1.7. Okay, so that concludes the lesson for today and for the week. Again, it's just the one lesson because it is quite lengthy. It's over 30 minutes in length. So if you guys could complete the homework at the bottom of the page, so page 286, 1 to 6, 8 to 10, and feel free to email me any questions that you have if you're confused with any of the information. Okay, I hope everyone has an awesome week, and we will touch back, or I'll talk to you guys soon. Take care. Bye.